In this video, I'm going to be explaining what the tangent ratio can do for us when we're solving a right triangle. So first, let's introduce this idea of trig functions. There are three main trig functions. They're called sine, cosine, and tangent. And each of them are really evaluating a ratio. And they're evaluating a ratio comparing two sides in a right triangle. Each of these are going to evaluate a different comparison. And today we're going to focus on the tangent ratio. So this TRIG acronym can help you remember these three formulas. SOHCAHTOA, and if you say it really quickly, it sounds like you're dipping a toe in a puddle, SOHCAHTOA. If you can remember that acronym, it's going to give you the three formulas you need to use these three trig functions. So today let's focus on the TOA, and let's figure out why TOA helps us remember the equation. So here is a generic right triangle, and we're going to use it to talk about the tangent ratio. So the tangent ratio is comparing the opposite leg and the adjacent leg, and that's relative to a specific angle. For example, if I want to talk about angle A in this right triangle, the opposite side from there would be across from it, and the adjacent side would be the side touching it or next to, and the adjacent side is never the hypotenuse. For sine and cosine, we'll actually use the hypotenuse, but we'll call it hypotenuse. So the adjacent side is never referring to the hypotenuse. It's always referring to the leg that is touching or the leg that is next to the angle that we're talking about. So the tangent ratio is the opposite over the adjacent side. If I find the tangent of this angle, my calculator will actually tell me the decimal equivalent when I compare these two side lengths. So trig functions are comparing two sides in a right triangle. The tangent ratio is specifically comparing these two sides. Let's do another example here. So it will change, the opposite and adjacent side will change depending on which angle I'm talking about. For example, if we're talking about angle A in this example, the opposite side length would be 24. The adjacent side length would be 7. So the tangent ratio for angle A would be 24 over 7. If we knew the angle measure, then the tan of that measurement would be this decimal value. And so your calculator won't give you this ratio in fraction form, it'll actually give you the ratio in decimal form, but you can convert that ratio to decimal and compare and make sure that you check your answer. Watch how it changes if I change the angle I'm talking about. Now if we want to find the tangent ratio for angle C, well now the opposite side length is 7 and the adjacent side length is 24. So the tangent to angle C would be 7 over 24, or its decimal equivalent would be this. So if we knew the angle measurement, we could use it to solve for one of these missing sides. That's what we'll do next. So how can we use the tangent ratio to solve for an unknown side length? Well, we have to know the angle measure in order to do this. So in this example, if we're talking about angle A, we're going to use 43 degrees when we substitute it into our angle measurement. The opposite side length across from that angle is side length A, it's unknown. The adjacent side length to this angle is 11. So when we substitute everything into our tangent equation, our TOA equation, then we're going to substitute the angle measurement that we know and the adjacent side length that we know, and we're going to solve for A. So whenever you solve a trig equation, you can set it up like a proportion. Always set that left side over 1 or put 1 underneath it, and now we can cross multiply to solve this proportion. So the tangent of 43 degrees times 11 is equal to whatever A is. And so ask your calculator and make sure you're in degree mode what the tangent of 43 is, and it should give you the decimal 0.933. So that's saying that some number divided by 11 should be 0.933. So we're using this proportion to figure out what it is. So if we multiply 11 by 0.933, then it should give us the A value. And it gives us a decimal that doesn't stop or terminate, and so we can round it to the 10th spot, or really to anything that the question is asking. And then we can check our answer. So supposedly 10.3 divided by 11 is equal to the decimal value of the tangent of 43 degrees. Well, we know that the tangent of 43 is 0.933, so we can check our answer here. And if we use that value that we didn't round, we'll be more accurate and it'll match up a little bit better. So 10.263 divided by 11 is the same exact decimal value that our calculator said the tangent of 43 degrees was. So angle measurements are determining side lengths. And this side length, or this height right here, would also be determined by this side length over here. Because if this was shorter, then this height would be shorter. And so this length has a lot to do with this angle measurement, but also has a lot to do with this adjacent side length that's connected to it. And so trigonometry is kind of putting that all together and saying that the tangent of 43 degrees has to be this height divided by 11. So this height divided by 11 has to be the same value as the tangent of 43 degrees. We can try out another one just to check and make sure we can do it. So again, we're solving for side length A. We know angle B measures 65 degrees. So the opposite side length from that angle would be the side length 24, and the adjacent side would be side length A. So when we substitute everything into our TOA equation, the tangent of 65 degrees should be equal to the opposite side, or 24, over the adjacent side, or A. And once again, we can set it up as a proportion and cross multiply. You can turn this into a decimal before you cross multiply, or you can do it after you cross multiply. It really doesn't matter. So the calculator tells us that our tangent of 65 degrees is about 2.145. To solve for A, we got to divide by that decimal. So A is 24 divided by 2.145, which is approximately 11.2. And we can check it. Make sure that 24 divided by 11.188 is the same thing as the tangent of 65, and it seems to match up. Not only can we use tangent ratios to solve for missing sides, but we can actually use inverse tangent ratios to solve for angle measures. So remember that inverse operations undo each other. Multiplication and division are inverses of each other, they cancel each other. Squares and square roots are inverses of each other, they cancel each other. In the exact same way, a trig function and its inverse trig function will cancel each other. So if we can use trig functions and angle measurements to find side lengths, we'll think about that upside down and inside out. Then the inverse trig function must be using side lengths to find angle measures. And we can actually look at it algebraically. Since our tangent of an angle is equal to the opposite over adjacent ratio, if I inverse tangent both sides, I cancel my tangent, I'm left with the angle measurement, and I end up doing the inverse tangent of our ratio on the right side. So this symbol, tan, it looks like it's being raised to a -1 exponent, but it's actually the symbol for an inverse function. So it's shortened to tan of -1, that's the inverse tangent. So really, to find angle measurements, it's almost purely done on a calculator. As long as we can set up our ratio, comparing the opposite to the adjacent side, then we just got to press the inverse tangent button on our calculator and it gives us our angle measure. So for example, I want to find the measurement of angle X here. Well, the opposite side length is 5. The adjacent side length is 12. If I use the inverse tangent of my ratio 5 to 12, in degree mode, my calculator tells me the angle measurement for angle X is about 22.6 degrees. And then we could check it. The tangent of that angle should be equal to the opposite over adjacent ratio. And so if I check it on my calculator, it does in fact give me the same value. We could solve for angle Y, but this time the opposite side length is 12 and the adjacent side length is 5. So if we do the inverse tangent of 12 over 5, in degree mode, our calculator tells us the angle measurement for angle Y, and we can check our answer.